Just minutes after the impact, something the science team had not fully prepared for appeared on their screens. NASA had just slammed a 2-ton rocket into the moon on purpose, and the cloud of dust it kicked up contained something the moon was supposed to be missing. For decades, scientists had treated the lunar surface as a dry, dead, hostile place. This single crash was about to prove that belief wrong, in a way nobody had expected. Stay with me until the very end, because the strangest part of this story is the part almost nobody is talking about. The moon has always looked pretty much the same from Earth. Gray, dusty, dead. For about as long as humans have pointed telescopes at it, scientists have agreed on one simple rule. The moon is dry. Sure, there might be some unconfirmed ice in the deepest, coldest shadows, but in general, the surface has always been treated like a desert with no water. That belief shaped everything we ever did up there. No one ever planned a moon base around drinking water because there was nothing to drink. No one ever planned a moon base around watering plants because there was nothing to grow. The moon was a place to visit, briefly, not a place to live. Then came a small clue in the late 1990s. The Lunar Prospector spacecraft, a modest NASA orbiter, was circling the moon and picked up a faint reading of hydrogen near both poles. Hydrogen, on a place like the moon, almost always means water, because water is just 2 atoms of hydrogen bonded to 1 atom of oxygen. Find the hydrogen, follow it back to the water. Lunar Prospector found the hydrogen, and nobody could quite prove where it was coming from. Some scientists thought it was just solar wind, particles from the sun smacking into the dirt and sticking. Others thought it might really be ice, locked away in craters that have not seen a single ray of sunlight in billions of years. That is when a small group of scientists at NASA Ames Research Center in California started sketching out a strange, almost reckless idea. What if we did not send another quiet orbiter? What if we sent a missile? What if we slammed something into the moon on purpose, on the darkest spot we could find, and watched what flew back out? That idea became a mission called LCROSS. The letters stand for the Lunar Crater Observation and Sensing Satellite. It was small, it was cheap, and it was built on a wild gamble. If scientists were right about the ice hiding in the shadows, the impact would kick it up into the sunlight. The dust would tell the story. If they were wrong, the mission would just be an expensive hole in the dirt, dug almost 400,000 kilometers from home, paid for by taxpayers who had been promised a real discovery. LCROSS launched on June 18, 2009, riding into space strapped to a much bigger spacecraft called the Lunar Reconnaissance Orbiter. Together, they left Earth on a single Atlas V rocket, lifting off from Florida. Once they reached space, the 2 probes went their separate ways. The Lunar Reconnaissance Orbiter did what it was built to do, mapping the moon from a high orbit. LCROSS kept the upper stage of the rocket, the big spent fuel tank called the Centaur, attached to it. That Centaur was supposed to be thrown away, the usual way rockets discard their empty stages in space. But NASA had a different idea. They would use it as the weapon. The plan was elegant and a little crazy. The Centaur, weighing more than 2,000 kilograms, would arrive at the moon first. It would slam into a permanently shadowed crater near the South Pole called Cabeus at roughly 9,000 kilometers per hour. The energy of that impact would be roughly equal to a couple of tons of TNT blowing up all at once. It would carve a fresh crater about 30 meters wide and 5 meters deep into the lunar floor and fling about 1,000 metric tons of soil high up into the weak lunar sunlight. 4 minutes behind the Centaur, the smaller LCROSS shepherding spacecraft would fly straight through that rising plume of dust, ice, and debris. The shepherding spacecraft was carrying 9 different scientific instruments, including near-infrared spectrometers, a visible light spectrometer, mid-infrared cameras, near-infrared cameras, and a total luminance photometer, all of them designed to study whatever was in that plume. After the fly-through, the shepherding spacecraft would also crash into the same crater, finishing its job in one final fiery plunge. The target was Cabeus crater, because earlier, hydrogen readings had lit up the darkness there. Cabeus is, by any measure, one of the coldest places in the entire inner solar system. Its surface temperatures hover around minus 390 degrees Fahrenheit, almost as close to absolute zero as anything on a rocky world can get. The sun has never warmed that crater floor. Not once in billions of years. If ice survived anywhere on the moon, this is where it would be hiding. When the night of October 9th, 2009 finally arrived, mission control at NASA Ames went quiet. The room that had been buzzing with engineers and scientists for weeks fell into a strange calm. Outside that room, telescopes all over the world, ground-based observatories, space-based cameras, even amateur astronomers with backyard gear, were pointed at the same tiny patch of the lunar South Pole, waiting. At 4:31 in the morning Pacific time, the Centaur hit. There was no sound. The moon has no air to carry it. There was just a flash of heat, a brief plume of debris, and then a silence that seemed to stretch across the entire sky. 4 minutes later, the shepherding spacecraft flew into that same plume, recording everything it could before it too disappeared into the dark floor of the crater. And then, for hours, nothing. The data had to be recovered. The numbers had to be checked. No one could say for sure what the mission had caught. Was there really ice in that plume, or was it just more dust? For days, the scientists sat with their screens, eyes straining for a clear signal buried inside all that noise. The first real answer came about 6 weeks later, on November 13th, 2009, at a NASA press conference. Anthony Colaprete, the L-Cross principal investigator, walked up to the microphones with a small grin on his face. Multiple independent instruments had detected water in the plume. Not a trace, not a hint. The signature of water was unmistakable. His exact words to the press were unforgettable. "We are ecstatic. Multiple lines of evidence show water was present in both the high-angle vapor and ice phases. But here is where things take a strange turn. That first announcement, water confirmed on the moon, was just the beginning. The real surprise came when the team went back through their data, looked deeper at the numbers, and started asking how much water there actually was. The answer, when it landed, was bigger than anyone had prepared for. Initial estimates suggested roughly 25 gallons of water had been kicked up by that single impact. Then the number climbed. Then it climbed again. Experts eventually calculated that the soil in the floor of Cabeus held water at roughly 5.6% of its total mass. Wait for that one. 5.6%. That meant the dirt in that one crater contained about twice as much water by mass as the soil in the Sahara Desert on Earth. Let that fact land for a moment. One of the driest places on Earth, the Sahara, the iconic graveyard of water, still contains water in its dirt. The floor of Cabeus crater, hidden in permanent darkness on a world scientists had called bone dry for centuries, contains twice as much of that water per gram of soil. Pause and imagine you are the scientist sitting in the room when that number came in. What would you say to the person next to you? What would you say to your family that night? And what L-Cross found next was even stranger. The instruments on the shepherding spacecraft did not only detect water, they also detected sodium, mercury, and silver, 3 different elements that should not have been easy to find in a small sample of moon dirt. And the more the team looked, the more they found. They began to see signs that the water was not just buried as ice. In some places, the water appeared to be present as a thin film clinging directly to the grains of lunar soil, tiny droplets of water baked into the dust itself, hiding in the dark for billions of years. This is roughly the point in the story where the room at NASA Ames started to feel the weight of what had just happened. A mission the size of a small bus had just turned a dry world wet. The discovery raised a question that nobody could answer that night. How did the water get there in the first place? This was not a small question. It was not something to file away for later. It went straight to how we understand the moon, how we understand Earth, how we understand the entire early solar system. And here is where the mystery opens up. There are a few leading theories, and each one is its own wild idea. One is that comets, those ancient dirty snowballs hurtling around the solar system in the early days, hit the moon billions of years ago and dropped their water into the dirt at the poles, where it got trapped in the coldest shadows and just stayed. Another is that the sun itself was the source, that solar wind carrying hydrogen ions slowly bonded with oxygen and lunar rock to create water naturally, over millions of years, in small amounts all the time. A third is that volcanic eruptions from deep inside the moon, long ago, erupted steam out of the surface, and that steam drifted to the poles and settled into eternal dark. Each of these ideas quietly rewrites something scientists had thought they understood. If comets brought the water, then the moon shares a deep ancient link with the rest of the solar system, a fingerprint of every impact in its history. If solar wind made it, then the universe is quietly assembling water on rocky worlds all the time, with no need for comets at all. If volcanic steam did it, then the moon was once far more alive than anyone thought, even briefly, in ways we never considered. And nobody, not yet, can say for sure which one is right, or which combination of all 3, or whether something stranger is going on. So hold that question in your mind, because every new mission to the lunar South Pole carries a quiet hope that the next sample, the next crater, the next set of measurements will finally tip the balance. And every answer is going to tell us something surprising about where we came from. Because the moon is more or less a piece of the same original material that formed the Earth. If they share water, they might share deeper history too. Now to the reaction, because the moment that first press conference ended, the news traveled around the world. Inside NASA, the reaction was almost disbelief. Anthony Colaprete, in a follow-up interview shortly after, told reporters the team had originally expected to find water, but only in trace amounts, just a fingerprint in the dust. Instead, the data showed something dramatically larger. Several buckets worth of water had been thrown up by the impact alone, enough to fill a respectable small pond by lunar standards. Colaprede's smile at that press conference was the smile of a man watching a theory he had spent a decade defending suddenly come true on a screen. Around the world, planetary scientists reacted in waves. Some were thrilled but cautious. They wanted to triple-check every instrument reading before declaring victory. Others were openly moved. For people who had spent their entire careers studying the moon, watching L-Cross confirm not just water, but a meaningful amount of water after one daring impact, felt like the moment a long, cold case finally cracked open. Others in the field were not convinced. Some scientists, especially those who had spent years modeling lunar chemistry, pushed back. The impact site is one crater, just one. Cabeus could be an unusually wet spot. It could even be a local accident of geology. To really understand how much water the moon holds and where, new missions would need to map hundreds of permanently shadowed craters, one impact at a time, until a real pattern emerged. The scientific community has split into two camps ever since. One camp believes the L-Cross discovery hinted at a vast planet-spanning cache of polar ice, frozen in place for aeons, just waiting for a future generation of explorers to reach it. The other camp believes Cabeus could be a rare exception, an unusually rich pocket of water in an otherwise dry world. NASA has already redirected several later missions toward this question. The Lunar Reconnaissance Orbiter, which launched on the same rocket as L-Cross in 2009, has spent years mapping craters all over the South Pole. ShadowCam, an instrument developed by researchers at Arizona State University and now flying on a separate Korean lunar orbiter, is designed specifically to peer into the inside of permanently shadowed craters, looking for bright patches of ice against the black crater floors. The Artemis program, NASA's current effort to land humans back on the moon for the first time in over 50 years, is pointed at the South Pole on purpose. Not because it is the easiest place to land, it is not, but because the water evidence makes those dark craters the most valuable real estate on the entire lunar surface. One of the older L-Cross team members described the psychology of the moment well in a later interview. Most of us went into the mission hoping we might prove there was a little water. What we walked away with was evidence that the moon is not nearly as dry and dead as we all assumed, and the most exciting part is that we still do not know what to do with that information yet. Zoom out, and the L-Cross impact is not just a small story about one crater. It is part of a much bigger shift in how scientists think about the moon and in how they think about worlds like it across the entire solar system. For a century, the moon was treated like a cinder, cold, dead, unchanged, the kind of place you fly past on the way to somewhere else interesting, the kind of place you assumed had been completely understood since the Apollo missions first landed on its surface. L-Cross reminded everyone that the moon was not fully understood. It reminded everyone that even the parts of it never lit by sunlight still have secrets. And those secrets are not small. They are not curiosities for academic papers no one reads. They could be the difference between a future where humanity briefly visits other worlds and a future where humanity actually lives on them. If you are watching this is not just science trivia. This is the beginning of something. Because water on the moon does not only change what we can do on the moon, it changes how quickly the first Mars mission becomes possible. Liquid water, broken into hydrogen and oxygen, becomes rocket fuel. A moon base that can produce its own fuel makes the rest of the solar system much more reachable. You launch from there, you refuel there, you go farther from there. The south pole of the moon, in a very real sense, is the gravel lot where the highway to Mars gets paved. And the implications go further. If the moon has been hiding meaningful amounts of water in its shadows for billions of years, then what about Mercury, which has permanently shadowed craters at its own poles? And what about other moons in the solar system, like Jupiter's Europa or Saturn's Enceladus, which are already thought to hide vast liquid oceans beneath their icy shells? Every observation L-Crossed made quietly applies to those worlds too. The same principles, the same darkness, the same trick of frozen water waiting where the sun never shines. Every time we send a robot, or eventually a human, into one of those shadowed craters on another world, they will be carrying the same wild gamble. Smash the surface on purpose. Watch what comes back up. Hope the dust tells a story we are not expecting yet. That, more than any single number from the Cabeus data, might be the real legacy of L-Cross. A new way of asking the universe what it is made of. There is something quietly amazing about a mission where the scientists intentionally destroy their own spacecraft, watching the wreckage on a screen, hoping to learn something no one has ever known before. NASA threw a 2-ton rocket at the moon on the darkest spot they could find, fully on purpose. They wanted to see what would fly out into the sunlight, and what flew out has quietly rewritten our understanding of the closest world to Earth. The moon is not dry. It never really was. It has been hiding something valuable in its shadows for a very, very long time. And very soon, The next mission, the next astronaut, the next footprint in the dust may finally show us how much is really there. If stories like this are why you keep showing up, hit that subscribe button. Galaxy Sphere is going to keep following this story. Every new finding, every new mission, every new piece of evidence as it lands. Drop a comment and tell me which part surprised you most. Was it the 5% water concentration in the crater floor? Was it the sodium and the mercury nobody had expected? Or was it the simple fact that we still crash rockets into other worlds to learn what they are made of? I read every single comment, and I genuinely want to hear what stuck with you. Until the next one, keep looking up.